So I've got a pretty rudimentary setup here, and basic setup I've been playing a lot with, driving a flyback transformer with a PWM drive unit and just powering it with a MOSFET using power supply about 12.5 volts. But what I have here is basically the secondary. You see through these little leads here, it's going right to this copper wire. Bend it in a little U here, and you see the leads are just barely forming a double spark gap. And this is about as low power a semi replication as you can get, I'd imagine. But I just wanted to see what would happen if I discharged the arc across this bar with this little neon here across both ends of the bar. Likewise, I've got a little tiny, what do you call them, grain of wheat bulbs or whatever, little tiny incandescent. That'll light up at about 6 to 8 volts or so. Takes very little current, but that's not going to light given the discharge I'm feeding it, which, if you'll notice, the neon does light, and I'm at a fairly high frequency. You disconnect that. So I'm driving it 26 kilohertz, 50% duty cycle. And when I turn the gate voltage down to make it more of a less of a plasma discharge, see, obviously there's less power in it. It doesn't light up as much. But even this fairly solid little plasma arc there, it's lighting it up. So more or less the same physics going on, you could say. Alright, now I've introduced a capacitor on the discharge here. So there's only, I'm actually not sure if I'm reading that right, but 1.25 kV. It's not very high. And I've got the smallest gap I can get here. And I'm only going to cut it on for a short period. See, the bulb is clearly coming on though. So again, this is loud, so I don't want to pop this capacitor too long. But now I've got another one behind the neon and one before the neon. So run it for a couple seconds. So you can see that one came on a little bit, but this one had the most intensity. So what is actually going on there? You know, what is it about these loads essentially being dead shorted on this side and then being pulsed on this side, causing them to light? And there's a lot of things, a lot of possibilities come to mind. How those actually correlate with the actual explanation of the hairpin circuit, I'm not really sure, but it's more or less, I guess, radio frequency demonstration, resonance, all types of stuff. In this setup here, I think it's actually more to do with inductor current and capacitor voltage, the inverse relation there. I think it has something to do with that.